Hello class, good day. Welcome to our Module 8 on the dynamics of rigid bodies. In this lesson, we'll be talking about the Newton's second law of motion. So, diba, as we know that Newton has three laws of motion. Now, we will be talking about the second law of motion. So, we're already done with kinematics. So, as we discussed in our previous chapters, in the first meeting, we talk about kinematics as describing or analyzing the motion of a specific body or of a particle without regarding the force. Now, in the kinetics, we will be tackling about the how forces affects the change of motion in a body. So, we're finally done with kinematics. Now, we'll be discussing kinetics. So, kinetics is a branch of dynamics that deals with the relationship between the change in motion of a body and forces that cause these changes. So sa kinetics na involved na dire si Newton's second law. Ingon si Newton nga, when an unbalanced force acts on a particle, the particle will accelerate in the direction of the force with a magnitude that is proportional to the force. Okay. So ingon siya nga sa to. So this is the Newton's second law. So ingon niya nga, when an unbalanced force F, so if natay force F acts on a particle, we can have that it is directly proportional to the acceleration. And they have noticed that the constant for the force, which is directly proportional to acceleration, the constant is that the proportionality constant that talks about the acceleration of the unbalanced force is the mass. So unsay pasabot nganong na relationship si force, si mass ug si acceleration. So it is just the same thing, no? If the particle, di ba? Kung mas magkabug-at ang iya ang mass by applying the same force, mas mo resist ang usa ka particle with proportional to the mass. So kung mas bugat ang kuan ang usa ka particle or usa ka object, and then you applied a force on it, so mas hinay ang acceleration compared sa katong mas gaan og mass nga particle or object applying the same force. So now we already talk about the unbalanced force. So in the statics of rigid bodies, di ba hisguta og balance force. So mo tag balance force, diri na to na-apply nga ang summation of forces along x is equal to 0, summation of forces along y is equal to 0. Now, if the forces acting on a specific body or a particle is balanced, it means that the particle does not move. Mo na siya ang statics. Now, we are already talking about unbalanced force. Sa ato pa, when an object is not in balance, so sabot wala siya nag-rest, it moves. So the object is starting to move based on the force applied to it and also siyang mass. So mo na siya nga pag-abot na nato diri ni dynamics, natay unbalanced nga force. Let's say we take the resultant of the force, it is just equal to the mass times the acceleration. So this is the concept of the Newton's second law of motion. So this is the mathematical form. Force is just equal to the mass times the acceleration. Okay. So the resultant force is kung sa ang direction ni resultant force, same siya og direction ni acceleration. Okay. So now let's talk about the rectangular coordinates. So unsa man ning rectangular coordinates? So in our previous topics, we are already talking about planar coordinates, right? Di ba nalang tayo duha ka components sa particle natin x and y. Now we will talk about the third coordinate, the z. So let's say we have a the coordinating system here. So last time we analyzed motion in 2D, now this is in 3D. So let's say this is the x-axis, this is the y-axis, and then this is the z-axis. Now, let's say that a specific particle is somewhere here. So last time we talked about only 2 components. Now we'll be talking about 3 components. So its distance from the origin, so this is the origin, towards this or towards here, we measure it as the x distance. Here the y distance, and from the origin to here, this is the z distance. So naa natay tulo ka components. Now if we already have 3 components, if natay unbalanced force niya, so the unbalanced force will also experience 3 components. You have the unbalanced force along x, the Fx. You have the force along y, Fy, and the force along z. This also applies since ang force ug ang acceleration is the same, they are related. So we can then realize that we have also the acceleration along x, the acceleration along y, and the acceleration along z. Since acceleration and the velocity are also related, then we can say that there is also an x component of the velocity, a y component of the velocity, and the z component of the velocity. So in engineering, we denote that the summation of forces is equal to the magnitude times acceleration, right? And since naman tayo tulo ka coordinates, then we can have a vector, the vector quantity for the force. So the summation, so ang forces is naman siya x, y, and z component. We can write it in vector as the summation of forces along x, I hat, plus the summation of forces along y, j hat, plus summation of forces along z, k hat, is equal to, di ba, na mass at times acceleration. So mass remains constant. So acceleration has 3 components also. So times the acceleration along x, I hat, plus acceleration along y, j hat, plus acceleration along z, k hat. So unsa ng I hat, j hat, and k hat? So the I, j, and k hat are just a unit vector. They tell us which direction this force goes. So for instance, di ba, ang force sa x is 10 Newton. So how do, let's say nagyata nga force nga 10 Newton. How do we know which direction does it act? Is it along the x component, along the y, or along the z? So we use the unit vector I, j, and k. So ang engineers, gagamit na sila I, j, and k. But to show that this is a vector, they put something like this in the top of I, j, and k. They call that I hat, j hat, and k hat. So it means then that kung so ato ning gibulag-bulag si kuan force ni x, y, ug z, and also ni acceleration x, y, z, we can write for each coordinate ingani. So the summation of forces x is equal to mass times the acceleration along x. The summation of forces y is just equal to the mass times the acceleration along y. And then the summation of forces z is just equal to the mass times the acceleration along z. So the magnitude of so since same gyapon sa atong curvilinear motion, di ba natin magnitude of acceleration. So napod tayo magnitude of acceleration diri. So the magnitude of the acceleration is scalar quantity. So it has not it doesn't show us the direction, but it has the magnitude. So we can have the ax squared plus the square of the acceleration along the y component, and then the square of the acceleration along the z component. So this is the magnitude of the acceleration. Since ang ato apong velocity is naman siya x, y, and z component, then we can also have the magnitude of velocity equal to, same thing yapon diri, this is just vx squared plus vy squared plus vz squared. So how about kung naanay kuan x, y ug z nga involved sa distance, unsay tawag nato ana? So this is also position. So diba in previous nga topics natay gigamit nga position nga symbol as S, that is for katong line lang nga kuan, plane system. Line lang gyud siya, then natay x and y. Now same siya gamay sa ano ni curvilinear. Generally we use the position R. This one. So ang position R, ang magnitude ani niya is just equal to, so R is just equal to the square root of, so kani nga square ani nga distance, square ani nga distance, square ani nga distance, so it's just equal to x squared plus y squared plus z squared. So kani x, y, z denotes distance ha. So distance paingon sa x along y and along z. So this is R, this is the position of the particle. So ang velocity is naputay magnitude of velocity is just equal to the summation of the square of the velocity along x, along y, and along z. Same also with acceleration.